be looking at here is it's going to be the derivative. It's really hard to do with d dx. All right, I'm just going to use the prime notation. A prime of b of x times b prime of x. Okay? Now, to understand what this means, it's much easier to understand once we look at a specific example. So now, you're taking the derivative of this whole thing. So you're going to take the derivative of this whole thing. Okay, let's just do it. dy dx. So now, it's this term cubed. So now we're going to take that cube. You have the function 3x squared plus 5 to the 1 lower power, which is 2. But then we have to take the derivative of what's inside here. Okay, that's what this is. So now this is going to be, derivative of this is 2 times 3 is 6, x to the 1. Okay, plus 5, derivative of 5 is 0. So my derivative here is that. So I could rewrite this as 18x times 3x squared plus 5, that quantity squared. So that's the chain rule. Okay. I'm going to take a look at a couple other chain rules once we get into some of our trig functions and our exponentials. Okay. So speaking of which, let's take a look at the derivative of cosine and sine. We're not going to worry about the derivative of tangent. It doesn't really come up very much, and it's kind of complicated. So now, let's just say that y of x is equal to sine of x. Okay. Now you're going to spend a lot of time in your math class doing this by definition, everything else like that. We don't have to go through all that. We're going to say that this is dy dx. This is sort of a specific and a general case. Well, I'll make it a more general case. A sine of bx. Okay, so now, this is going to be b times a. Let's do this. A sine of x. This is going to be a cosine of x. So it's a general and a specific kind of put together. So y of x is equal to a cosine of x. Well, my derivative, and this is an important difference between the two, negative a sine of x. Okay, so these two are kind of like general and specific put together. Okay, but a lot of times we don't have sine of x, we have sine of 3x. Okay, your position is equal to, x is equal to 5 cosine of 8t. Okay, we want to figure out what the velocity is. Okay, so we have to look at a little bit more of a general case. This is where being able to do the chain rule comes in handy. So now, let's just say y of x, we'll do a specific example here, is equal to 15 sine of 8x. Okay? Now, chain rule tells us how to do this. dy dx. Okay, we're going to take the derivative of 15 sine x. So that's going to be 15 cosine of the function, which is 8x, times the derivative of this. What's the derivative of 8x? Okay, n is equal to 1 here, so it's 1 times 8. The 1 lower power, which would be 0. So that's times 8. So I have to put an 8 in front here. I don't like to put the 8 afterwards. You think it's cosine of 8x times 8. Doesn't really work. So dy dx in this case is equal to 120 cosine of 8x. Let's take a look at a cosine example. Say y of x is equal to uh, 200 cosine of 15t squared. Ooh. Uh-oh. Well, we're just going to do what we did before. And we have the chain rule involved. Just that the derivative is a little bit more complicated. So it's going to be 200 negative sine, so I have to put a negative out front here, sine of 15t squared. Okay, that angle, okay, that argument of sine remains the same. Okay, times the derivative of this. That's 30t. Okay, 30t to the 1, so that's 30t. Sorry for squishing that. So I wind up with negative 6,000t sine of 15t squared. Okay. Now, let's take a look at exponentials. This is really easy. Y of x is equal to a e to the x. The derivative, y of x, is equal to a e to the x. Ooh, nice. Okay, the derivative of this is itself. Okay, there are more complicated examples. Okay, that we have to use chain rule for. So let's just say y of x is equal to 10 e to the 3x of 10 e to the 3x. So now dy dx, okay, it's just the function, okay, the derivative of an exponential is itself, so it's going to be the 10 e to the 3x times the derivative of this. So that's going to be the derivative of 3x is 3. So I wind up with 30 e to the 3x. Okay, that's pretty much what all of what we're going to see as far as calculus is concerned, and that should pretty much tidy up everything. As far as anything else, please ask me on the blog, and I'll be next week. I'll get up chapters 3 and 4 on the blog as well, but this should cover us for chapter 2 and any calculus deficiencies you might have. It doesn't mean that you're going to be comfortable with calculus yet. It's just trying to give you a working knowledge so that you can use it. When you get to Mrs. Giordano's class and she asks you to do it the long way, you do it the long way because you're trying to actually get comfortable with it. I'm just trying to make it so you're functional, functionally literate. You're not fluent in it. This is Mrs. Giordano is trying to get you fluent in calculus. I'm just trying to, give you a working knowledge. So I will see you again. I guess I'll get up chapters 3 and 4 next week.